So it should be on. All right. Hello, everyone. Thanks for joining for the DesignSafe webinar. We're going to take about 5 minutes and let our stragglers join us. We found that at the webinars, no one's on time. So rather than them missing out on those first 5 minutes, we're just going to take a 5-minute intercession here, and then we'll start up. How do I mute this? Here? Hi, everyone. If you're just joining us, we're just going to wait a few more minutes and then we'll get started. All right, hello everyone. My name's Ellen Rathje. I'm the Principal Investigator for DesignSafe, and I want to welcome you to this webinar today talking about what's new in DesignSafe. So what I'll do today is I'll first start off with some general overview of DesignSafe for some of you who are joining us may not be familiar with DesignSafe, but then I'll get into the details of some of the new functionalities that we have available, as well as some of the exciting things we see researchers doing within the DesignSafe framework. A few ground rules before I get started. If you've used Zoom before, or if you haven't, you'll see if you mouse down on your window, a bar will come up and there is a chat window. If you have any questions during the presentation, please put them into the chat window to everyone. We've got a couple of staff members from DesignSafe in the room with me that'll help me answer, will either answer those questions during the webinar or I'll answer them at the end of the webinar. So let's get started. So perhaps you might be asking yourself, what is DesignSafe? I like to describe it as a web-based research platform that provides you tools that you want to use in your research, typically to manage, analyze, and understand the critical data that we're using to understand natural hazards. Our vision is that we want the cyber infrastructure to become an integral part of the research process. We want it to be something useful for you, not just for, say, data sharing, data publishing, but also the research you do every day. So to achieve that vision, we provide a platform for the important part of that, which is data sharing and data publishing. But then also enabling research workflows that you'd like to do. We're giving you access to high-performance computing. And then we also deliver cloud-based tools that support this type of data analysis and visualization that you are doing in your research. And this, by providing cloud-based tools, that means as your data sets get bigger and larger and harder to move around, email to colleagues, students, we can more efficiently use that data, because with the data in the cloud and the tools in the cloud, we really can take advantage of that big data in our research. And then finally, DesignSafe, as part of the Natural Hazards Engineering Research Infrastructure, or NHERI, we want to amplify and link the capabilities of natural hazards researchers here in the US, but also around the globe. So if you go to the DesignSafe website, the URL is indicated here, you'll see something like this. What I really want to focus on today is what we can offer with respect to research. And so that means looking at the research workbench, which you see here involves a data depot, a workspace, a reconnaissance portal, some tools from our partners at the NHERI SimCenter, and then all importantly, the user guides that help you better to help you use and understand how to use the tools and functionalities that are available. So let's take a closer look at that research workbench. The first is the Data Depot Data Repository. And this data repository really has many levels of access. So first you have a private space called My Data, which is private to you, where you can store files, move them around, use them in analysis, etc. If you want more of a collaboration space, you can create a project under My Projects, and here you can share data with project team members, and ultimately it's the data that are in projects that then can be published. And so then we move on to the published space, which are it's the publicly accessible space for curated data that, again, come from My Projects. And then finally, we also have an area called community data, which is also publicly accessible, but it's a little bit of the wild, wild west. It's a little uncurated and less formally organized than the published data. So that's the data repository. But as I mentioned, we want to be more than just a data repository, and that's why we created the Discovery Workspace. So this is where you'll find the apps and the tools that you can use for computational simulation, data analysis, visualization, and those tools all have access to files that are in the Data Depot. Moving on, we have the Reconnaissance portal, which is our way to better discover, more easily discover published data from reconnaissance of hurricanes, earthquakes, etc. And then, as I mentioned earlier, our partners at the SimCenter have some research tools that are working to advance simulation. I'll talk a little bit about those today as well. So jumping into the data depot, so if you enter the data depot, you'll see the different areas on the left: my data, my projects, published, and community. Those are the areas I talked about previously. And here you see on the right, these are all the projects in which I am a team member. Some of them you can see I'm a PI, some of them I'm just team members and I have access to the files. Importantly, I want to point out over here, Box, Dropbox, and Google Drive. If you use any of these cloud service providers, you can link your account to DesignSafe. It doesn't automatically sync, but what you can do is you can transfer files from, say, your Box account into the data depot a little bit more easily than the web interface, which would be done in this through this add button. If you're like me, my laptop is completely backed up on Box through the university, and so I can more easily grab those files through the cloud interface than necessarily using the web interface. Now, if we think about projects and wanting to publish projects, we need to think about data models. We got to talk about curation. Our goal and our philosophy for data curation is to provide you structured yet flexible data models that support different types of research. So when you create a project, at the beginning you don't necessarily have to identify a project type, but if you're going to publish it, you will ultimately need to put it into one of these 5 categories: experimental, simulation, hybrid simulation, field research, or other, which basically encompasses everything except the first 4. Okay, so each of these have a slightly different way the data are organized. They have slightly different metadata requirements that are relevant to those different types of data. Now, if I take you through just a little bit about the curation, just to give you a high-level idea, and I'll show you some screenshots. The first thing you need to do is define your categories, and this is going to help you organize your data and have later users better understand that organization. Then you assign those categories to different files or folders. So those are the things that you're going to want to publish within each of those categories. You can also, for individual files, add additional tags of metadata. That's optional, but if you wanted to say, well, this file gives you a loading time history, this file is acceleration, you could do that as well. And then you relate those categories, which really provides the higher level organization. Now, if you've curated data in DesignSafe anytime over the last 3 years since we've had our curation interface, you'll see if you go there today that it looks and works a bit different. So let me show you some slides. We've tried to make this as seamless and as easy as possible. So here's an example project. And you can see that when you come into this project, you'll see 3 areas here: the working directory, the curation directory, and the publication view. This working directory, it's just however you want it. Every files, folders, organized however you'd like. But when you want to start to curate, when you hit that curation directory, things will look a little different. Similar files and folders are available, but now you see this add experiments, add categories, relate data. And notice this is an experimental project, so that's why we're talking about experiments. Now, what you then have to do is decide how you're going to organize your data. So here's an example. This is some centrifuge data. They actually have a digital data report that runs over the entire experiment. They have files that represent the model configuration. They have files that are going to represent the sensor information. And then the events, which are the different types of events where data have been collected, such as different shapes if you're on a shaking table, different wind loads if you were doing a wind tunnel test, are represented by the events. And you can have multiple events within one model and sensor. Again, multiple sensor configurations within one model, etc. So this is our tree, our category tree. Once you've defined those, then you need to start assigning them to files. This is where, if you used it earlier, you might have been like, well, how do I assign the categories to files? Well, now the place where to assign them are right underneath each file or folder. So we've tried to make that easier. Here where the tags go. And now, when you're done, or maybe not done, you want to say, well, how is this going to look like in the publication view? You hit publication preview, and you'll see what it'll look like. So this is what the experimental information will be, and you can see now the same organization as the event tree. And as you would open these files via these arrows, each of those categories would show all the files within there. And then when you finally feel good about how this looks, you hit prepare to publish, and you continue on your way. But please note, when you hit publish, we mean it, you're going to publish, and it will eventually, within about a day or so, end up in the published area. Of course, we can help you if you've made some mistakes, but we try and avoid that. We would prefer to avoid that if possible before you hit publish. So that was very high level, of course. So we do have more detailed guidelines, which you can find at this URL, which is under the user guide area of the research workbench. A couple of things to note about the field research data model, which was only recently released in the last month or so. Predominantly for field reconnaissance. Currently, the way it's organized is via, under a project, we've got mission and then collections of data. This is mimicking the data model that the NHERI Rapid Center uses. And currently, our categories and metadata are very focused on engineering research. But we know that there is an important component of social science research that's also related to natural hazards. So we're working with Lori Peak and Converge and her social science reconnaissance organization to expand the data model for social science research. We're working on that really hard right now. And you know, in the next few months, we'll be putting that out so that the social scientists have a place to put their data in our data depot. Last thing to mention about curation, we have our data curator, Maria Esteva, and then our colleague, Mayar Sharifi, who actually has a PhD in civil engineering, but works here at TAC, so he really understands the science behind the data. The two of them work together to have curation office hours, Tuesdays and Thursdays at 1 p.m. Central or by appointment, and you can find more information about that at this URL. Maria and Mayar are really great. They can, if you're not sure how you want to organize the data, they can give you some tips, some advice, etc. I do want to make one important pitch about understanding how to best make your data count that you've published and give credit to data you've used from others. So the first step, which we provide, is helping you formally publish your data sets in a stable data repository. So check, we have that. And I want to encourage you to think not just about experimental data, but also the processing scripts that you used, visualizations, simulation data, etc. All of it can be published. But that data should have a permanent DOI, a digital location, not just a URL. URLs change, DOIs are permanent, and if the data moves, changes URLs, we can change where the DOI points for that data. And then most importantly, if you use data in a paper and want to cite it, please don't put it in the acknowledgments. Please don't put it in the body of the paper. Formally cite it in your reference list, the same way you would do a paper. You've got the DOI, and we even make it easier on you. We give you the citation language. So here's an example of a recently published project. And you see, here's the DOI, here's the citation button. If you click that blue button, it gives you the citation perfectly. It's got all the authors, the date, the title, and then how to deal with the fact that it's design safe, it's not a journal, and then there's your DOI. So again, please do this. This helps us track data reuse. It helps you track who's reusing your data. So moving on to the reconnaissance portal, this is our map interface with data sets that are related to reconnaissance events. There has been a lot of events in the last few years. You can see lots of blue pins on this map. On the left-hand side, you can see, you can get access to all the different events. You can either click on a map pin, or you can actually do a search. When you click on one of those events, for instance, the Kaikoura earthquake in 2016, which I was involved with, you can see the data sets that are, the available data sets are listed here. Some of these, for instance, the GEAR Reconnaissance report is actually a link to the GEAR website. But here, this landslide inventory, when you click on it, it actually takes you to the data depot. And this was a landslide inventory that I generated with a graduate student that is now available for people to use. This was published in the old interface, so you see the older projects look a little bit different when you look in the published area than the newer ones, so just keep that in mind. But still, we still have that citation button trying to help you cite these data sets appropriately. Something that's really exciting that just happened in the last few months is our integration with the RApp mobile app, which has been generated by the NHERI Rapid Center. So if you're involved in rapid research, you may get one of their iPads that has the RApp app loaded on. You're collecting data with the RApp app. What you can do is you can then log in with your DesignSafe credentials, and all of your projects that you've created are available for you to transfer the data from that iPad to the DesignSafe project. So this is actually, the iPad is talking back to the Rapid Center, and then the Rapid Center is sending it to your project. So that's really exciting. You do need to create a project through the web interface in DesignSafe first, but then you can very easily get the data into your project for sharing with your colleagues, and then ultimately for publishing. So let's move on and talk about the Discovery Workspace. This is the area where those cloud-based tools reside, as well as HPC, high-performance computing enabled codes are available. And again, these have access to files in the data depot. They're generally organized with respect to simulation codes, visualization, data processing, partner data apps, utilities. Utilities actually is just simply compress and extract, so that you can say zip files in and out before you bring, after you bring them in, or before you take them out. And then my apps are private apps that you may be testing. So if I just kind of list some of the highlights of some of the tools available, if you're thinking about data analysis in the cloud, again, you've got big data, it's in our cloud, you want to analyze it, you don't want to download it, well, MATLAB's available in our cloud to do that analysis, make some plots. We have batch processing that can be take advantage of the Stampede supercomputer. You do need to be at an academic institution to have access to MATLAB, but that's all we need to check. Now, if you're more into open source, Jupyter is another option that allows you to do data analysis. Although Jupyter, I think, is a lot more than that. It's an electronic notebook, really, that supports Python code, R code, anything you can do in Python and R, you can basically do in Jupyter. And I'll show you some examples. For visualization, we have HazMapper, which I often call the poor man's Google Earth, but I will say here the DesignSafe version of Google Maps. So you don't have to be a GIS expert, put some pins, put some pictures, and you'll see, and you can share them easily in the cloud. As people are becoming more, or using more point cloud data from LiDAR or structure from motion, viewers such as Potree are important. Here with Potree, you can create, view, and analyze point cloud data without being an expert and having to deal with those huge blast files. Again, point cloud data is big, so this is a great opportunity for the data and the tools to be in the cloud and work together. If you are more of a GIS expert, need more than what HazMapper can provide, we do have the open source QGIS available within the workspace. And then a couple of last things here for visualization that are very specific to the ADCIRC storm surge code. Kalpana converts data from output data into GIS files, and FigureGen allows you to do some plots for those outputs. So lots of different options. We also have ParaView, which if you've used that, it's a really high-end visualization code, and we have that available as well. Let me just give you some examples here. Here's an electronic notebook in Jupyter that Scott Brandenburg from UCLA has used on lots of his projects, where you can notice here you've got something that almost looks like a paper. You've got equations, etc. But if I scroll down, you'd see the actual code is in there. There's actually some processing going on. And then at the bottom of the notebook, they've actually created kind of a tool where you can pick the sensor, it plots the data, you can window it, you can look where this is where the sensors are located. So they basically created their own little app to better explore the data that is in their project, their published project. I took the opportunity to use Jupyter to publish a script that has helped me move research to practice. So we had an approach that did probabilistic seismic hazard analysis for the sliding displacement of slopes. This is in the published area, again, the older version, so it looks a little different. But that's where you can find this Jupyter notebook. And if you just put in the latitude and longitude of your site, it'll pull all the hazard, ground motion hazard curve information from the USGS, bring it into the analysis, and then generate with other information you provide within the notebook hazard curves for the displacement. Okay. And then another user can use this as is. They can also copy it to my data and start building off of it and modifying it. So that's exciting as well. Going back to a previous example I showed you for the Kalpana earthquake, where that landside inventory we published. Well, the landside inventory could be brought into HazMapper. So as I mentioned, that's our kind of Google Maps app. And what you see here is when you open the HazMapper app, in this case, for this project, the red areas represent landslides that were observed. These are geotag pictures that we brought in. And the blue and the pink represent track logs from GPS track logs. So all that stuff can be overlaid together. And we're adding a lot more new functionalities in HazMapper that we're going to be excited to release in the next coming months. Talking a bit about Potree. So in terms of Potree, you do need to convert your kind of raw LAS files into a Potree format. So you run the Potree converter, then you can run the Potree viewer on what comes out. And then just in your browser, you'll see something like this. This is a temple from the Nepal earthquake. And the screenshot here, unfortunately, doesn't show all the tools, but you can start measuring things, looking at angles, measuring distances. And so you can really start using the point cloud data to do some technical work. And just to demonstrate how we should be referencing and citing data sets, this is a data set that is in DesignSafe, and so here is the data set as published in DesignSafe. That's the citation. So let's move on to computational simulation. This is really where a lot of the HPC comes into play. There's a huge user base for OpenSees that does finite element analysis for structures and soil systems. We have several different versions of OpenSees. One we call OpenSees Express. This is for smaller jobs. It runs on a virtual machine. It doesn't run on the supercomputers. But OpenSees MP and SP, which are both parallelized, MP to run many jobs, SP to partition big jobs, they both run on Stampede 2. And if you're interested in more details, we have an archived webinar from last year that explains the differences and how to use them. Just this spring, we released OpenSees Pi, which again, it's OpenSees, but it's got a Python interpreter instead of a Tickle interpreter. And it's available through Jupyter. And we did a webinar in May that's also archived that you can take a look at if you're interested. And coming soon, one of the is STKO, the Scientific Toolkit for OpenSees, which provides some pre and post processing. If you've used OpenSees, particularly as a geotechnical engineer, it can be difficult to build the models within that code framework because there is a lot of visualization of where the elements are. And STKO helps you build those models and then ultimately post-process the output that comes out. We're also working with GID for those who have used that with respect to OpenSees and looking to make that available in the cloud as well. The key to having these in the cloud is that you can make your inputs in the cloud, run them in the cloud, post-process them in the cloud, and all you have to do is download the processed output to start writing your paper. Another code that people may be interested in is LS-Dyna. So this is another finite element code. You can analyze for structures as well as for soil. Now here, you do have to have a formal license with LS-Dyna. We do have to check with the folks at LSTC that your license is active, but it's pretty simple. You submit a ticket, we check for you, we give you access, and this runs on the Stampede 2 supercomputer. We, again, this spring, gave a webinar talking about the details about how to run LS-Dyna in different modes, particularly if you're trying to do lots of analyses, and I say lots of ground motions, etc. So that's archived as well. Finally, the pre and post processor that many people use for LS-Dyna, which is LS pre-post, is also available within the workspace. Now, moving away from those two codes, which I would say predominantly are used in the earthquake field, we do have OpenFOAM, which is used for computational fluid dynamics. And this has been our focus of, say, the last 2 months of really making sure that this runs the way researchers would want. So we've been working with some wind folks as well as some water folks. And we'll be having at least one webinar coming up this winter with respect to how OpenFOAM works within our interface. If you're part of the storm surge community, you'll be familiar with ADCIRC. We have several versions of ADCIRC available, the serial version, the parallel version, and then the parallel version that also includes the detailed nearshore wave dynamics, PADCIRC plus SWAN. So all those are available, running on the supercomputers, because that type of analysis and the domains that are run typically need the supercomputers. We did a webinar in March, so again, that's archived, and I'll show you where to find all these webinars at the end of this webinar. As I mentioned earlier, we have some of the tools available that ADCIRC researchers typically use, such as Kalpana to convert NetCDF to shapefiles to bring into GIS, and FigureGen to create images directly from that output. Related to that is another code, or in terms of the same domain, is Kalpana, ClawPack and GeoClaw, which is a PDE solver that's often used for storm surge modeling or for tsunami analysis, and that's available as well. Now, all those tools are available from the web interface, but they also can be accessed from the command line. So our vision here is that putting these codes in the workspace lowers the bar for new users wanting to come in and trying to use HPC. But ultimately, you may want to do something somewhat unique. You need the flexibility of the command line. So that's why they are still available. They're also available at the command line, but it does require you then to get a proper and formal HPC allocation from us. And our allocations policy is on our website. It's a much easier allocation to get than if you'd submitted for an exceed allocation, but we need to understand what you're doing and how it fits in with natural hazards. All of these codes can also be accessed through Jupyter, and we have several researchers who are actually creating workflows within Jupyter where they do the pre-processing, then they call the code, then they do the post-processing. But this does require some knowledge of our API, Agave, which is also changed its name to Tapas. And so there's some additional training, but if you're interested, we can talk with you about that. So let me just give you some examples of some things that folks have used DesignSafe to do. So here's an example from Durante et al., which was presented in the GESD conference last year in Austin, where they wanted to look at seismic earth pressures on retaining walls. So they used OpenSees Express to run 30,000 parametric analyses. All the output was saved to the data depot, but they didn't want to download 30,000 output files. So they used MATLAB in the data processing tab to process and post-process that data, and ultimately only the processed data needed to be downloaded. Then they used that data to develop analytical expression to predict earth pressure from the input time series and the model properties. And then those analytical expressions were coded into Jupyter to make a neat little tool where you can put in the time series and some of the properties, and then you can look at some of the predictions of the seismic earth pressures. In terms of an ADCIRC workflow example, and I will note, these are workflows, but they're not automated workflows. We're working towards automated workflows, but here You can do all of these steps in DesignSafe. And this workflow we built around a question that was actually asked in the shortly after the Hurricane Harvey that hit the Houston area, the Gulf Coast of Texas. They said, what addresses should the firefighters want to know which houses we should go to check, and because of the storm surge. So we kind of turned that around and kind of made a hypothetical question of what addresses will be inundated on Galveston Island by storm surge from the impending hurricane. So we ran this workflow where we computed the storm surge water levels with ADCIRC. We converted the net CDF output to shapefile using Kalpana. We imported the results for GIS along with other data, elevation data, property location data, and then ultimately identify addresses that had been affected by the storm surge. So here, again, the workspace, we ran ADCIRC, the output was placed in my data, then went to Kalpana, took those output files and converted them to shapefiles, and then went into QGIS, which actually opens in a window, and that's where the data integration of the storm surge, the elevation data, and the property locations resulted in. These red dots represent the areas that would have been inundated by this storm surge on this elevation. You can see that this area of higher elevation is right here by the seawall Galveston. That's where everybody should have ran to, I guess. That's the safe area. These are all the lower areas in the back that were inundated. So let me talk a little bit about our partners at the SimCenter. Their mission is related to ours, but is very focused on producing software, new software that's extensible by researchers, so you can use it in your research. The focus is developing an open source computational framework that builds workflow applications that also include uncertainty quantification. So the key is workflow, and here we're talking about automated workflows, and then also incorporating uncertainty. So they want to design that framework, but they want it to be flexible, extensible, and scalable by researchers, so any of it can be enhanced. And of course, to show how it works, they need to seed that framework with enough data and interfaces so in the near term, people can use them and then ultimately build off of them. And then release these tools and applications that use this framework. To date, 4 research applications have been released, all of them working on the building level side, not regional scale. So we've got UQ, which is uncertainty quantification for finite element modeling, EE for earthquake engineering, WE wind engineering, and PBE performance-based engineering. You know, the unique features, you know, as I've already mentioned, uncertainty quantification, event selection. What's really interesting about these tools, you download them locally, and you can run them locally if you don't need any high performance computing, but you can execute them remotely on DesignSafe's or intact supercomputer using the DesignSafe API. So in that way, you're really going from the SimCenter tool through DesignSafe to Stampede 2, and then the outputs are put in your data, and you can run with your post-processing data analysis. And here's the URL to find those research tools. They are working on regional scale, scaling that up to regional scale analysis using a tool called RDT. The data that they use here are harvested and combined with image processing as well as artificial intelligence. So very exciting to create the proper inventories of the infrastructure. And they're working on 3 test beds, 1 in San Francisco, 1 in Anchorage, both for earthquakes, and then looking at Atlantic City for storm surge and hurricane wind. The back-end application for RDT is called RWhale, and I have to say, I really like that name. It's a great acronym, a regional workflow for hazard and loss estimation. And this back-end application is available from the workspace in the simulation area. So if you want to take it for a run now, you could do that here. Also, the SimCenter has released 4 educational applications that, again, are downloadable, executed locally, but they're for educational purposes. So looking at multiple degree of freedom response of structures to earthquakes, looking at lateral loading of pile groups. Here, interestingly, looking at responses for earthquake versus wind time series. So those loadings are quite different. And then looking at brace frame analysis. And here's the URL to learn more about those educational applications. The last thing I want to talk about is the partner data apps that we have available. There's several here, but the two that I really want to focus on are the NGL, Next Generation Liquefaction data set, and the SCEC Broadband Ground Motion Portal. These are both Jupyter-based tools that access archived data sets. So the key is the tools make it easier to access those data sets. We did a webinar on these two tools in February, and you can get more information there, but I will show you some screenshots. If you're not familiar with NGL, you can see they have their own website, and they're developing a community database of liquefaction case histories. And through this web interface, people can submit data that gets curated into their data set, but it's limited in terms of your ability to do large-scale data analysis from this web framework. So their data is housed in a SQL database, which makes it useful for doing large-scale data analysis. The schema is indicated there. You can read about it at that URL. But daily, the database is replicated to DesignSafe. And then they publish Jupyter notebooks that will access the data available in DesignSafe. And those Jupyter notebooks are available through community data. And here, these slides I got from Paulo Zamaro at UCLA. So this is really a partnership between NGL and us to provide access so we can do large-scale data analysis. And just last week, we talked to the folks, if you're a geotech on the line and you've heard of the New Zealand Geotechnical Database, we're looking at a way to maybe do something similar with that database as well. But so if you click on the NGL Jupyter Partner app, you'll be brought into Jupyter. These are all the Jupyter notebooks that they have available that can look at their data. First, here's a CPT viewer, so you can pick a site and you can look at the cone penetration test versus depth, the tip resistance, the skin resistance. So you can very quickly look at different CPT. You don't have to, write your own code to plot these type of things up. If you want to do, say, a little bit more sophisticated data analysis, maybe you're not familiar with how you could query a SQL database, they actually have some example queries. So they can show you the commands that are used to, say, pull out data from specific sites under specific queries, and then you can create your own subset of data that then you ultimately do your data analysis. And as for the SCEC broadband tool, these are simulations that were done by SCEC, Southern California Earthquake Center, using their broadband platform. They're simulations of ground shaking from design level events for both Northern California and Southern California. The time series are actually published in the published area of DesignSafe, but they have created a Jupyter notebook that'll help you better search and select motions that you may want to use as input to an analysis. And so these are bigger magnitude events, which we often don't have a lot of recorded ground motions for, so that's why they're useful. So if you open the Jupyter notebook, you'll see the ground motion portal. This really looks like a tool. It doesn't look like code, although you can read the code if you want. You put in the magnitude range, say the distance range, maybe whatever intensity measure you're looking for. You can then visualize the results. So those are the spectra of the motions that were selected. And then you can save those search results. You can save them and download them, or they can go into My Data. And so here you can see that's the name. There's a folder with all the files and data related to that search. So you're ready to run some OpenSees analyses with the motion selected as input. So obviously I gave a very broad overview of what we have available here in DesignSafe. If you want to know more, if you want to get into the details, I encourage you to go to the Learning Center. This is along that top bar of the DesignSafe website. And if you mouse over it, you'll see education and training. And if you, on that page, you'll find a listing of the DesignSafe tutorials, the SimCenter webinars. They have lots of webinars. There's other webinars that we have archived as well. There's information at this this site also for the curation office hours, workshops run by the experimental facility. So lots of information under this education and training section of the Learning Center. You'll also notice some of these webinars, not only can you watch them on YouTube, but they may actually have published a notebook in community data that you can then build off of and work through as you watch the tutorial. We do have some upcoming DesignSafe webinars that I want to mention. In October, date is still to be determined. Barb Simpson from Oregon State will be talking about using Jupyter in the classroom. She's done some great work bringing Jupyter into the classroom to teach dynamic structural analysis. And then two others that we're looking at for the near future. Jamie Paget at Rice talking about leveraging OpenSees and cyber infrastructure for modeling seismic fragilities. And as I mentioned earlier, using OpenFOAM and DesignSafe for wind engineering problems. We're working with Hassan Kareem and his students on developing that. So let me end here with saying what I love to say, which is DesignSafe, we are open for business. We're here to help you do more research, better research in natural hazards engineering. You don't have to be an NSF-funded researcher to use DesignSafe, so it's available to anyone doing natural hazards research in the US as well as around the globe. One of the best ways to interact with us beyond the website is to join the DesignSafe Slack team. And here, if you go to the menu at the top of the DesignSafe website and go under NHERI Community, you can go to the Slack online collaboration and learn more. You should have gotten the Slack invite when you joined DesignSafe, but often that email gets lost in the cloud, so to speak. So if you've already got an account and still want to join, you can just submit a ticket, and we can get you brought on board. And just to give you an idea what Slack is, it's really an instant messaging system. So within DesignSafe, we have these channels. So for instance, here's a Jupyter channel, and you can see people saying, oh, I had this problem, and then Julia fixed it real quick, and everything was ready to go. You can also direct message people as well. So this is I always have this open on the bottom of my laptop, and it's really a useful tool. The last two things I want to mention, I already mentioned cite your data with DOIs in the reference list. I'll say it again. And the last thing is one way that we're trying to better track how DesignSafe is affecting research is to ask researchers to cite what we call our marker paper, which we published in Natural Hazards Review in 2017, if you use DesignSafe in your research. It's nice if you put it in your acknowledgements, but putting this in the reference list makes it much easier for us to track, say using Google Alerts, who's using DesignSafe, what research has been influenced and enabled by DesignSafe. And as you go and explore DesignSafe and use it, I'm always looking to hear feedback, new ideas, new things that you think you can do. How was your experience, good or bad? Because what we're trying to do is really create the best platform possible to enable the best research that we can. So with that, you've got my email, and I will see what type of questions we might have from our users. So Tracy, who's in the back of the room.
Yeah, so we have a good question about, to use DesignSafe, do I have to have a funded project?
Okay, that was a great question, which I just answered in the last 1 minute of my talk.
I know.
But I'm going to say it again.
Okay.
These tools are here for researchers to use. It doesn't cost us any more to add one more user who maybe isn't funded by NSF. If you can use what we've developed, go ahead and use it. We've got researchers from New Zealand. We're working with researchers in Taiwan. We're reaching out to folks in Europe. They obviously aren't funded by NSF. So even within the US, if you're not funded by NSF, but it is natural hazards related, we're happy to help you.
We did answer the question, but maybe you could speak to a little bit about, our publications do not have direct integration with Google Scholar. But do you want to talk about the Google searches that once you have a publication in our site?
Right, so I think we're in an evolving time period now of how people deal with data DOIs. So Google Scholar is still very focused on the DOIs related to papers. But we're working to make sure our DOIs are discoverable by Google so that you can search Google via your DOI and be able to figure out which papers have cited your data. But we're certainly in a new world. It's moving quickly. I can tell you 4 years ago, I tried in the ASCE Geotech Journal to cite data with a DOI in my reference list, and they changed it back to a URL. They didn't even want to use the DOI, so I was flabbergasted. We've moved beyond that. That's good. But it's still a little bit of way to go to track those data citations the same way we can track the paper citations.
There's not really a lot else. We'll have the webinar posted. Somebody is asking like where they can download your educational software.
So the educational apps that the SimCenter provides is within the SimCenter website, which you can access through DesignSafe. So across the top of DesignSafe, hold on here, where you see NHERI facilities here, if you do that drop down, it'll show SimCenter, and on their website, you will see their you see access and information for those tools. And all of the SimCenter tools, research as well as educational, are available from that URL.
Okay, we have a really good question about what's the protocol for private industry folks to engage with DesignSafe?
That's a very good question. So in terms of using data that's published, I don't think there's any problem with anyone using anything published, any published data, etc. Or even published scripts. I mean, they're out there, they're to be cited. When we talk about using specific resources such as, say, high-performance computing, we can't provide access to high-performance computing for consulting that, that's giving you a leg up on, say, your competition for other private industries. But if you're in private industry and you're doing research, we're happy to work with you there. We really want you to focus on either doing research or helping bring research to practice. Those are the two places that I think the industry folks, we can serve you. And if you have any questions, send me an email and we can talk about whether it's appropriate for you to use DesignSafe in your work. Anything else? All right. Let's see. You have just a little bit more. You have like 1 more minute, otherwise, I know Tracy and Charlie, who are in the back of the room, it looks like they did a good job answering your questions via the chat window. Are we able to save the chat window? I don't think we are.
I don't remember how he does that in the recording.
Okay, let's see. So funding opportunities if we can contribute to the DesignSafe system. Great question, because we really have built this to be community extensible. We don't necessarily have funding opportunities where we will fund researchers to do work, but we generally have, I would say, give free consulting to researchers to help them do what they want to do. And so if you have an idea, we can work with you to make it happen. We can provide some folks who understand the back end of DesignSafe to help you, make an app available through DesignSafe, etc. And if you're submitting a proposal to NSF or even other agencies where you want to take advantage of DesignSafe and really maybe take us in a new direction, you can put funding in to support us, support some of our software engineers to work directly with you. I've written many support letters for research proposals so that people can put those in their proposals and realize that we are on board with what they're proposing.
We have one more question. It said, any comments about UTRC?
I am not sure what UTRC is.
So we have a UT System Funds research consortium that gives time on the supercomputer, but.
So right now, all our allocations are provided through DesignSafe. Now, if you have an allocation through UTRC, that would be something for Lone Star 5, you can also access that. The way you've that's typically through the command line. But then if you wanted to use the DesignSafe tools, say for the post processing, etc., we would certainly be available for that. All right. Well, I appreciate everyone's participation. As I mentioned, I look forward to seeing what folks are doing in DesignSafe. Keep your eyes out for the next webinars, because we're going to be focusing on webinars about how to use DesignSafe to do research. And I think there's be some really interesting things and really spark ideas what other people can do. All right. Thank you, everyone. Bye.